Before we leave the topic of mediation testing, I need to say a few words about the power that is needed to detect an indirect effect. And so the citation that is my go-to for this is Fritz and McKinnon, and the citation is located in the notes at the bottom of the slide, and this article is also posted on Blackboard. Please don't let all the formulas intimidate you in this piece. The only place I really go in this article is to Table 3. And that's what I'm showing you here on this slide. It's on page 237. And they did a bunch of simulations with different effect sizes on the A path and the B path, so different B weights. And this is what they found for the different types of testing of mediation. So they did the BK method, various types of BK method. Those aren't important to know unless you're doing the Baron and Kenny method for some reason. So I just ignore the top rows of that table for the most part. I ignore joint significance. I've never done that one. But we have the Sobel test and the bias-corrected bootstrap, which is on the very last row. So those are really the only two I've ever looked at, and but the bias-corrected is probably the one that's used the most. Those are the bootstraps that are available in process, and so if you're using the process macro, you would go directly to the last row of that table. Now, the columns of this table are a little bit confusing, but they indicate the A path is the first letter and the B path is the second letter. And those letters correspond to different beta weights that you expect to find on those paths. So an S represents a beta of 0.14, I believe. An H represents like a more moderate B weight of 0.26. An M represents a 0.39. And finally, an L represents a 0.59 beta weight. So depending on what kind of beta you expect to see on your A and B paths, that is the column that you would look in. So let's say you expected your A path to be very small, that would be an S, but you expected your B path to be an M or a 0.39. So you would check the SM column, and it shows you that you would need 400 individuals in your study in order to test with the bootstrap method and get up to a power of 0.8. That's really important. So right below where it says Table 3 at the top, it says empirical estimates of sample sizes needed for 0.8. So that means you have an 80% chance of rejecting the null when the null is indeed false in the population. Now, let's say you expected that your A path would be very large and your B path would be an M. Okay, so an LM would be what you need. And so you go to that column. It's like the second to last on the far right. The LM, and it says that you would need a sample size of 54 only for a 0.8 power. So that's not bad. That large effect size on the A path really is helpful. So this table has been very helpful for me for dissertations and for estimating. And again, remember, we don't know exactly what our beta weight's going to be, so we just have to take our best guess with our previous research on the topic perhaps, and also looking in the literature at studies that have been previously done that are similar to yours.